Close your eyes for a moment and imagine a place where the world feels unfinished. The horizon stretches endlessly, yet nothing interrupts it, no trees, no hills, no landmarks to give the eye rest. Just white earth merging with a sky the color of cold steel. The wind does not announce itself with drama. It arrives suddenly, slipping through seams in clothing, biting exposed skin with a precision that feels intentional. At 40 degrees below zero, the air itself seems hostile, as if it resents the presence of life. This is the Arctic tundra in winter, a landscape so stark that at first glance it appears empty. No movement, no sound beyond the wind, no visible signs that humans could ever belong here. There are no forests to break the gales, no fallen branches to gather for firewood, no soil soft enough to dig with bare hands. For half the year, the sun does not rise at all. Darkness settles in and refuses to leave. And yet beneath a low mound of stone and frozen earth, there is warmth. Inside that mound, a family sits in quiet comfort. The air hovers around 70 degrees Fahrenheit. Children sleep. Clothing dries. Water melts slowly from ice. A single flame flicker in a shallow stone bowl, steady and calm. There is no roaring fire, no smoke-filled room, no furnace rumbling in the background. The warmth does not feel forced. It feels held. This structure is not an igloo, not a cave, and not a temporary shelter thrown together in desperation. It is a karmak, a semi-subterranean winter house, refined over centuries. From the outside, it barely rises above the tundra, almost invisible against the snow. From the inside, it feels alive. Every curve, every material, every opening exists for a reason. This is not survival by brute strength. It is survival by understanding. To grasp how such homes came to exist, we have to travel back to around the year 1200, during a climatic window known as the medieval warm period. At that time, shifting temperatures caused sea ice to retreat across parts of the Arctic. Open water expanded, and with it came giants. Bowhead whales, some weighing up to 60 tons and capable of living for 2 centuries, began migrating deeper into the Canadian high Arctic and Greenland. Their arrival reshaped the ecosystem, and following them came people. The Thule were master hunters and navigators, ancestors of today's Inuit. They traveled in large skin-covered boats called umiaks, capable of carrying families' tools and supplies across frigid seas. They carried toggling harpoons designed to anchor into thick blubber. They understood currents, ice behavior, and animal movement with an intimacy earned through generations of observation. But their journey was not driven by hunger alone. They were also following opportunity. Whales provided meat, oil, sinew, and bone, but they also opened access to trade networks and rare materials. Native copper and meteoric iron scattered across the Arctic from ancient impacts allowed the Thule to craft tools unlike any others in the region. Their migration was not random. It was deliberate, strategic, and ambitious. As they moved nearly 3,000 miles from Alaska toward Greenland, they encountered a problem that threatened everything. In Alaska, forests supplied driftwood. Homes could be framed. Fires could be fed. But as they pushed east, the trees vanished. The tundra offered no timber at all, and winter was coming. 6 months of darkness. 6 months where exposed skin could freeze in minutes. There was no time for trial and error, no margin for architectural mistakes. Whatever they built had to work immediately, or people would die. The solution did not come from the land, it came from the sea. The whale would not only feed them, it would become the very bones of their homes. When wood disappears from the world, your definition of architecture changes. For the Thule, the absence of trees was not just an inconvenience, it was a total rethinking of how a home could exist. There were no beams to cut, no planks to shape, no forests to draw from. Everything that would support life had to come from what the Arctic did provide, and the most abundant, durable material available came from the largest animal on Earth. A single bowhead whale was not merely a successful hunt, it was a structural gift. Its body offered an entire catalog of architectural components, each shaped by nature to handle immense stress. The lower jawbones or mandibles were the most prized. Each could stretch up to 15 feet long, naturally curved and extraordinarily strong. Where wooden beams would snap in extreme cold, these dense bones held firm. They became the primary rafters of winter houses arching overhead, like ribs of a cathedral. The ribs themselves were lighter and slightly flexible, ideal for secondary supports. Shoulder blades were broad and flat, capable of forming flooring or partitions. Even the massive skull could be used as an anchor point, stabilizing walls against shifting ground. Nothing was wasted. Bone replaced lumber and baleen. The flexible filtering plates from a whale's mouth replaced rope. Cut into strips, baleen could be lashed tight, shrinking as it dried, locking the structure together without nails or metal fasteners. But bone alone did not create warmth. The real intelligence of these houses was hidden underground. Beneath the Arctic surface lies permafrost soil that remains frozen year-round, sometimes hundreds of feet deep. Above it sits a thin, active layer that softens briefly in summer before refreezing. The Thule understood something critical about this environment. While air temperatures swing violently, the temperature below ground remains remarkably stable. It hovers just below freezing, even when the air above plummets to lethal extremes. To access that stability, they dug. This was slow, brutal work. Using antler picks and whalebone shovels, they waited for the short Arctic summer when the sun softened the surface, just enough to scrape away inches at a time. Progress was measured in patience, not speed. The ground fought back, refreezing overnight, resisting every strike. But eventually they carved pits 3 to 4 feet deep into the earth. That depth changed everything. By sinking the living space below ground level, the house dramatically reduced its exposure to wind. Wind is not just cold air moving, it is a thief. It strips heat through convection, pulling warmth from any surface it touches. At minus 20 degrees, strong wind can make the body lose heat as if it were minus 50. Above-ground walls bleed energy constantly. Underground walls do not. Once the pit was complete, the whale bones were raised. Mandibles arched upward to form a dome, a shape chosen not for beauty, but for physics. Domes distribute stress evenly. Snow slides off instead of piling up. Pressure from wind and drifting ice presses inward, strengthening the structure rather than collapsing it. The Thule didn't calculate load-bearing equations, but their designs obeyed them perfectly. Over this skeletal frame, they layered tundra sod. These were not loose blocks of dirt. Each slab was cut thick, dense with roots moss and compacted soil. The slabs were stacked root side inward so the living fibers would intertwine, sealing gaps as they froze together. Over time, the house became almost organic. Roots locked into one another. Ice filled microscopic cracks. The structure healed itself season after season. From the outside, the house blended into the land, a low mound barely distinguishable from the surrounding tundra. From the inside, it felt solid, insulated, and permanent. This was not a shelter meant to survive a storm. It was a system designed to endure generations. In a land that offered nothing easily, the Thule built homes that borrowed strength from the earth itself. At the center of every winter house, in the place of greatest importance, sat a small object with enormous responsibility. It did not roar, it did not flare, it barely moved at all. Yet without it, nothing else in the house mattered. This was the Quillic, a shallow lamp carved from smooth soapstone filled with rendered seal oil, its flame floating quietly on a wick of dried moss. In the Arctic winter, this lamp was not just a tool, it was life itself. For 6 months of darkness, when the sun never crested the horizon, the Quillic provided the only light inside the home. Its glow defined the rhythm of the day, such as days existed at all. It melted ice for drinking water. It warmed stiff fingers and thawed frozen food. It dried clothing soaked with snow and sweat. It cooked meals slowly, carefully, without smoke filling the room. All of this came from a flame no larger than a hand. Managing that flame required constant attention and deep knowledge. The responsibility belonged to the woman of the household, and her skill determined whether the family lived in comfort or risked disaster. Seal oil was precious. Burn too hot and the supply might not last until spring. Burn too low and the cold would creep inward, settling into bones and lungs. The flame had to be steady, balanced, almost meditative. This was not passive heating, it was active stewardship. But the Quillic presented a deadly paradox. A flame consumes oxygen and produces carbon monoxide. In a tightly sealed underground house, this could silently suffocate an entire family while they slept. Yet opening a hole or window would undo all the careful insulation, allowing precious warmth to spill into the night. European builders struggled with this problem for centuries, often failing catastrophically. The Thules solved it with elegance. Their answer was the cold trap entrance. Instead of placing a door at floor level, they dug a long, narrow tunnel leading into the house. This tunnel sloped downward from the outside, dipped to a low point, and then rose again into the main living space. To enter the home, a person had to crouch, crawl, and climb slightly upward. At first glance, it looked inconvenient. In reality, it was brilliant. Cold air is heavier and denser than warm air. When it enters the tunnel, it sinks and settles at the lowest point, unable to rise into the living area. Warm air inside the house, lighter by nature, floats upward and stays put. The tunnel functions like a U-shaped pipe, trapping cold the way plumbing traps water. Heat does not escape. Fresh air still enters. The flame keeps burning safely. This passive system required no doors, no valves, no moving parts. People could come and go without flushing warmth from the house. Even during storms, when the outside temperature plunged further, the interior remained stable. The physics did the work. Inside the living space, the air was warm but never stale. Smoke from the Quillic drifted upward instead of spreading horizontally. Oxygen was replenished slowly and continuously. The balance was delicate, but once established, it held for months. The Quillic was more than an engineering solution. It was sacred. Its flame symbolized continuity, protection, and the presence of life in a world dominated by darkness. Letting it go out was not just inconvenient, it was deeply symbolic, associated with loss and danger. The woman who tended it was not simply cooking or heating. She was maintaining the boundary between survival and extinction. In the Arctic, warmth did not come from abundance. It came from precision. And at the heart of that precision burned a single unwavering flame. To an outsider, the winter house might appear sealed, buried in earth, wrapped in sod, guarded against the wind with obsessive care. But this impression is misleading. The Thule did not build houses that merely trapped warmth. They built houses that breathed. At the highest point of the dome, directly above the living space, they cut a small opening no wider than a hand. This opening was called the Kanak, a word that translates simply and precisely to nose. The name was not poetic decoration. It was functional truth. The house inhaled and exhaled through this point, maintaining life inside through constant invisible motion. As the Quillic burned and bodies released heat, the warm air rose naturally toward the ceiling. Warm air expands, becoming lighter than the surrounding cooler air. As it collected near the roof, it created gentle pressure, pushing stale air, smoke, and moisture upward and out through the Kanak. This outward flow created a vacuum so slight it could not be felt, but physics responded instantly. Fresh, oxygen-rich air was drawn inward through the entrance tunnel below, replacing what had been expelled. The result was a continuous circulation loop. No drafts, no sudden temperature loss, no suffocation. The house renewed itself moment by moment, powered entirely by heat that already existed inside it. In modern terms, it was a passive ventilation system tuned perfectly to its environment. Inside, the organization of space followed the same logic. The family did not live on the floor. Along the walls, they built raised sleeping platforms from stone slabs, packed earth, or salvaged driftwood when available. These platforms rose 2 to 3 feet above ground level. The reason was simple and profound: heat rises. Measurements taken centuries later showed that air near the ceiling could be 20 degrees warmer than air near the floor. By sleeping higher, wrapped in furs, the family occupied the warmest layer of the house. Children slept closer to the wall, elders closer to the center where heat was most stable. The architecture itself enforced efficiency without rules or reminders. The floor, meanwhile, remained cold, just above freezing. Rather than fight this, the Thule used it. Meat, fish, and blubber could be stored safely along the edges of the floor, preserved naturally by temperature alone. Food was close at hand, but never spoiled. The house contained both warmth and cold, each precisely where it was needed. These homes were not static, they adapted with the seasons. During autumn and spring, when mobility mattered more and daylight briefly returned, families often used a structure known as the karmak, a variation of the winter house that shared the same semi-subterranean foundation, but replaced heavy sod roofs with animal skins stretched over bone frames. These lighter coverings allowed more light and airflow, making the space flexible without sacrificing thermal stability. As contact with outsiders increased, new materials appeared: wooden crates, canvas, scraps of metal. But even as materials changed, the logic did not. New elements were absorbed into an existing system rather than replacing it. The ground remained the anchor. The airflow remained deliberate. The relationship between heat, height, and movement stayed intact. To the Inuit, this was never just engineering, it was meaning. The entrance tunnel was understood as a birth canal. Entering the house symbolized returning to the womb, a place of warmth, safety, and protection from a hostile world. The kanak was the nose. The kulik was the heart. The house was alive. In some regions, the entrance was framed by massive whale jawbones curved overhead like open arms. To step inside was to be swallowed by the great whale itself, an animal that gave food, fuel, tools, and shelter. Home was not separate from nature, it was formed from it. In a land where exposure meant death, the Thule did not barricade themselves against the world. They built shelters that listened, responded, and breathed along with it. In the Arctic, survival was never an individual achievement. No matter how well a single house was built, no family endured alone. The cold was too relentless, the darkness too long, the risks too unforgiving. What sustained Inuit communities through the worst periods of history was not just engineering, but connection. During the onset of the Little Ice Age, when temperatures dropped even further and storms grew more violent, villages adapted once again. Houses were no longer isolated points on the tundra. They were joined beneath the surface by narrow tunnels carved patiently through frozen ground. These passageways allowed people to move between homes without stepping into lethal cold. A child could visit grandparents. A neighbor could share food. Elders could gather to teach and remember. All of it happened underground, out of the wind's reach. At the center of many villages stood the kagik or kurigi, a large communal house. This was where celebrations were held, disputes resolved, and knowledge preserved. Storytelling was not entertainment alone. It was education, memory, and survival strategy passed orally from one generation to the next. In these spaces, techniques were refined, mistakes discussed, and lessons encoded into songs and myths. Architecture supported culture, and culture preserved architecture. This partnership with the environment endured for centuries, but it was fragile in a way no storm could threaten. In the mid-20th century, that balance was abruptly broken. Colonial authorities, convinced that modern Western housing represented progress, relocated Inuit families into prefabricated frame houses. These structures were designed by architects unfamiliar with Arctic conditions. They sat fully above ground. Their walls were thin. Their windows leaked heat. They lacked cold traps ventilation logic and any understanding of snow, wind, or permafrost. The results were disastrous. These houses required constant fuel to remain livable. When fuel ran short or systems failed, interiors froze rapidly. Moisture condensed inside walls, causing rot and mold. Families accustomed to shared warmth were separated into isolated rooms. The kolik was removed. The woman's role as keeper of heat and balance disappeared overnight. What had once been an integrated system of survival became dependency on distant supply chains and external maintenance. The loss was not only physical, it was cultural. Knowledge that had taken centuries to refine was dismissed within a single generation. Yet that knowledge never truly vanished. Today, there is a growing movement to recover and reinterpret these ancestral designs. Rather than treating them as artifacts, researchers and builders are recognizing them as functional blueprints for resilience. Semi-subterranean construction, passive ventilation, thermal zoning, and community-centered design are suddenly relevant again, not only in the Arctic, but everywhere. In 2021, a team in Inuit constructed a massive communal snowhouse using more than 1,200 blocks. Dozens of people gathered inside, comfortably warmed almost entirely by body heat. No furnaces, no fuel lines, just geometry, insulation, and physics working together. It was not a nostalgic experiment. It was proof. As modern societies face rising energy costs, unstable climates, and increasing isolation, the lessons of the Inuit feel urgent rather than ancient. They remind us that efficiency does not require complexity, that sustainability does not demand domination, and that comfort can come from cooperation with natural forces rather than resistance to them. The Inuit did not conquer the Arctic. They listened to it. They observed how cold air moved, how heat rose, how the ground held steady beneath chaos. They used permafrost as a foundation, whalebone as structure, sod as insulation, and air itself as a valve. Every element served multiple purposes. Nothing was wasted. Their homes teach us something modern architecture often forgets. A house is not a machine. It is a relationship. And perhaps the future does not lie entirely in new technologies or unfamiliar solutions. Perhaps some of the answers we are searching for already exist, written quietly into the stone, bone, and earth by those who learned long ago how to live in harmony with a hostile world. All we have to do is remember how to listen.